Hi, I'm Producer Fun, and in this video I will show you different options to align our 3D scan to the coordinate system, to the global coordinate system. The two options, or the two software options that I will be showing you, is using Exstar Hub. Exstar Hub is the software that comes with the einstar rocket or the einstar 2. From my knowledge, the Exstar Regal, I guess it's called, for the scan Regal, also supports the same alignment functionality. And then I will be looking at Quicksurface. And Quicksurface is a proper reverse engineering software. It is paid, keep this in mind. So difference, Exstar Hub is like free to use and included with the scanners. If you have them, you can also just download the scanning software and use the post-processing measurement functionality. I'm not even logged in at the current point, and I can still use these functionalities. Whereas Quicksurface is a paid software. There is like a basic, a light license for roughly 400 euros per year, and there's a pro license that I have for roughly 1,500 euros per year, or I guess it's also 5 grand for a lifetime license. So there's quite a big price difference. But of course, you also notice this one in the functionality to some degree. For what do you want to use the alignment at all? For this to understand, I will just now open the model I will be using for alignment. It's a scan of the DJI Action 6. I actually took the scan with the einstar rocket. And when we now look at it or try to orient it to the coordinate system, you can directly see the model doesn't line up at all with the coordinate system, or the global coordinate system. This is most of the time the state you get when you scan, and then the scanner doesn't have like an external reference of what should the global coordinates be. But as soon as you want to use the scan, for example 3D printing or further usage in CAD software like Fusion or SolidWorks, you need the model to be properly aligned to the coordinate system. Otherwise, working with it will be quite hard. Most of the time, when you load the STL file, the mesh file, you have the option to manually transform it, like to use drag and drop sliders to rotate it around the different axes, like here, and then you can rotate it to the side. But this is most of the time not accurate enough to actually use it. So if I want to create sketches or like 2D sketches, I need the model to be perfectly aligned. Otherwise, there's no real use for me, at least for me, where I mostly do reverse engineering. So let's start with the alignment in Exstar Hub. There are actually multiple options for alignment. As you can see, here is the alignment. There's 3 options in Exstar Hub. You have precise alignment, 3-to-1 alignment, and quick alignment. Precise alignment is this kind of manually dragging the model around until it is aligned. So like here, and as you can see, I can just rotate the model, and I can offset the model. Oh, let's undo the offsetting. Then there's the option for quick alignment. This is actually quite a nice feature, I must say. For example, 3D printing, or if I just want a quick version of the scan to share online, where I won't be using it for reverse engineering, so the alignment doesn't need to be as precise as with other scans, but I still want to have like a initial alignment that works for me, and therefore allows proper presentation of the scan. In the quick alignment option, you simply manually orient the scan in like the perspective you want to have from the frontal view. So now this is the view I want to be the front, and then I click on align, and as you can see, the coordinate system was placed accordingly. And in the next step, I also can move the coordinate system to the bottom of the model. This is quite nice if you want to like render the scan where it will be placed on like a virtual floor, and the rendering is or you have different lights and there most of the time the origin is on the bottom of the part. So now we have like a rough alignment. We can actually move it a bit to the side now, where you can see, okay, it isn't actually accurately aligned. For this, we will first, for the precise alignment now, we will first be extracting like features from the model, and then you will use the features to align the model. So the alignment is actually based on scan data. Quicksurface later will feature kind of similar approach, but with like a bit easier workflow. So now first we need to create features. What do we need to align a model? Basically we need a plane that's for the y and z axis most of the time. Then we need a line and a point. More easily you can also use 3 planes and then create the line and the point from the intersections between the planes and then from the intersection between point and line. So let's do it like this. Let's first create the 3 lines. Here in Exstar Hub you can use different methods for fitting. You can either directly pick points on the model. We won't be using this because the nicer option is using the best fit. Best fit basically means that you just draw on the object, like here on the mesh directly, and now it will automatically create the plane for you. It tries to like fit it as nicely into the scan data as possible. Of course, for this fitment to work, it should be an actual plane and not like the curvature here on the side of the ray. When using best fit, keep an eye on having the setting to only select visible mesh paths, because now if I toggle it to select through and I select data again, you can see it also selected triangles on the back. And now if I create a plane, it created it on the back side. Or now even worse, if I have this selection, it will be off simply. But now let's delete the additional planes we won't be needing and continue with our 2 additional planes we will need. So first nearly trapped myself. Let's create this plane, and I will be needing another plane here at the side. And I have an eye on not selecting any data that's like part of the curvature. So now I have 3 planes, and in the next step I will creating myself the line and the point, because in Quicksurface to use the 3-to-1 alignment you need a plane, a line and a point. For the line you could theoretically again pick points, but I will be using the plane-plane intersection. This is like the nicest way I think there is. So I can just select these 2 planes, and now it will create myself a line that intersects the 2 planes. For the point, it's the same. You can either pick a point on the scan itself or use a line-plane intersection. When selecting the planes or the features to use, of course, the line has to intersect with the plane. So if I now would be using plane 1 and line 1, there would be, it fails because there would be infinite intersection points. So let's change this to plane 5. And now you can see it correctly created me point 1. And now if I go back to alignment, 3-to-1 alignment, I can just pick my different features. So for the plane I will be using plane 1. For the line I will be using line 1, and for the point using point 1. And now, as you can see, the alignment was successful. But first let's change this. I want the plane 1 to define the, actually I wanted to define the y-axis. Y+ axis. This looks nice to me. So now my model is fully aligned, and if I now try to move it like a bit to the bottom of the screen, you can see it's nicely aligned. Okay, this was the workflow within Exstar Hub. Now let's try to do the same in Quicksurface. This is the 26th version of Quicksurface. It just came out a few months ago, but the functionality for alignment is basically the same as for the 25th version. So we will simply open our mesh file again, and then if I have it opened, I can select Prepare Scan. This is like the easiest way to reach this. This just takes you through all the steps necessary to do an alignment. So I will do next. Here we can actually create a symmetry plane. That's quite nice. We will use it later for like a second alignment option. Now we'll skip it. And now I can just use this kind of magic brush. That's quite nice. And if I do it again, I can just select here in front. I can actually use this slider to edit the strength of the selection. Create the first plane. Now we will need the second plane at the bottom and the third plane at the side, like this. Okay. We can now go to the next point, and I will select the bottom plane first to define my z-axis, and I can now flip it. So the z-axis points to the top. What's now nice in Quicksurface, I can now directly use the other planes to define my other axes. So I don't need to go through the steps of creating a line and a point. So now I can apply and I'm finished with the alignment. The result is basically the same as in Exstar Hub. Now, one of the more interesting functionalities, I would say, is creating a symmetry plane for the alignment, or using a symmetry plane for the alignment. Because if I look at the coordinate system now, my origin is like here on the left bottom of the mesh, and normally I like my origin to be in the, at least for some axes, in the center of the part, so if I can make a nice orbit around it. So we will again select the scan and use the prepare function, but now we will draw a symmetry plane. In Quicksurface, it's basically like you initially start with your manual drawing, or like a rough idea how the plane should be placed, and then it uses with the rebuild function like automatic fitment to try to create a plane that fits way more nicely. But as you can see, these like optics are a bit of a problem because they aren't symmetric. So I can just use the manual sliders. In Quicksurface, you also have the option to directly analyze the deviation between the symmetry or the mirrored meshes. This helps quite a lot when aligning. But I would say the threshold is at 0.1 millimeters for the green. This should work for us. So I can go to the next step. Now I have my first plane. Now I will use this plane again and the bottom plane. And now we can go back to alignment. So, and it looks quite nice. And as you can see, now the origin is centered to the model. So yeah, this was my short alignment tutorial for scans. I know there are multiple other possible ways. You could use a mesh mixer, which also have like this manual alignment for drag and drop, or of like manual transformation. Fusion also has this functionality when importing meshes. Of course, there's like size inspect, there's geometric, but I just wanted to demonstrate you the tools I'm comfortable with and that I mainly use.